All right, we're doing section 6.3, solving compound inequalities. We have the problem negative 5x is less than or equal to 2x plus 3 is less than 7. So the first thing we have to do is take a negative 3 in all three locations. And we end up with a negative 8 is less than or equal to 2x is less than 4. Now our next step, we need to divide by 2. In all three locations. And we end up with a negative 4 is less than or equal to x is less than 2. Now once we get our compound inequality, we are going to graph it. So you need to draw on a number line. So you're going to draw your number line. You need to look at the numbers that you have. We'll put a negative 4 over here. On the other side we'll put 2. Add a few points, 0, and we'll also put negative 2. Now when you're graphing this is an and. So your line's going to go together. You got to make sure, again, you got your open circle for less than and greater than symbols. You got your closed circle for less than and equal to and greater than or equal to. So at the negative 4, because x is greater than or equal to negative 4, we're going to have a closed circle. And we're going to be, our solutions will be going up the graph. On the other side, we have x is less than 2, so we go to 2 and we have an open circle, which means that 2 will not be part of the solutions. And we're going to be going less than, so we see our final solution. When we cover in our graph, we have a closed circle at negative 4, we have an open circle at 2, and all our solutions basically go from negative 4 all the way to just short of 2. An example in compound inequalities is an or. The first example was an and. You can see the equation 6x minus 5. 6x minus 5 is less than 7, or 8x plus 1 is greater than or equal to 25. What we have to do in these situations, we have to solve each inequality. So we're going to solve the left side, and we're going to go plus 5 on both sides of the inequality, and we get 6x is less than 12. We divide both sides by 6, and we get x is less than 2. So we will graph that here in a little bit. On the other side, we have 8x plus 1, and so what we're going to do is take a negative 1 to both sides, and we get 8x is greater than or equal to 24, and we will divide by 8 on both sides, and we will get x is greater than or equal to 3. Now again, we have to graph these on a number line, so we'll draw our number line. Now these are compound inequalities, and there's the or in between, so we have a choice. So let's graph x is less than 2. So on our graph, I'm going to put 2. Also I'm going to put 3. I'm going to put 3, 4 over here, and I'm going to put 2, 1 over here. Now, as I graph, I'm going to have an open circle. So it does not include 2 as my answer. and then I'm going to shade, all right, to the left-hand side. All right, I'll put my arrow because all the answers less than 2 will satisfy that inequality. The other side of the inequality, I'm going to put a closed circle at 3. All right, so I'm going to have a closed circle at 3, and this is greater than, so this side would be satisfied, all right, by all of the answers that are x is greater than or equal to 3. So 3 would be included in these answers. Third example for compound inequalities, we have a -3 is less than a -1 minus 2x is less than or equal to 5. Now in this problem we'll end up having to divide by a negative on both sides of the inequality. And whenever you divide by a negative or multiply by a negative on both sides of the inequality, you're going to have to flip the inequality sign. So first thing we're going to do is we're going to solve for x. So first thing we'll do is we'll add a +1 to both sides, or in all 3 locations of the inequality, combining our like terms, and we'll end up with a -2 is less than or equal to -2x is less than or equal to 6. So we've isolated our -2x in between. Now we're going to divide by a negative on both sides of these inequalities. So as we're dividing by a -2 in these locations here, our inequalities are going to have to turn. So what happens here, we end up with 1 is actually greater than, x is greater than or equal to -3. Now, we could leave it like that. We're going to write it the correct way of writing it, then would be to flip this. All right, so what you actually have, if you think about it, I have, it's an and statement. We'll put x in the middle. All right, we're going to turn around, we're going to put it over here, we're going to go is less than or equal to a -3, and then on this side it's going to be less than 1. All right, so now we have on our number line, we can graph this. All right, so again, this is the best way to write this. This is the best way to write, as we like to say right here, this is the best way to write this inequality. So you have to take a look at it when those inequalities flip like that to turn around and write it the correct way. So let's graph this on the number line. So we'll have a -3 over here. We'll put 1 over here. On this side, we're going to have x is greater than or equal to -3. So we'll have a closed dot at -3, and we'll be going up the number line. Right. On the other side, we're going to have x is less than 1, so we'll have an open dot. So 1 will not be part of the solutions for this inequality. And so there is our graph for -3x is less than or equal to x, or is greater than or equal to x, is less than or equal to 1.